A basketball is thrown vertically with an initial velocity, and assuming freefall conditions with the following gravitational acceleration, part A asks us to find the maximum height of the ball. So what we do is choose a coordinate system with an origin at the initial position of the ball and a direction. So here we have a single interval of motion because it has the same uniform acceleration. So the maximum height of the ball is h. And we know that at the maximum height, the velocity of the ball is 0. So therefore we know the following quantities, and we can solve for the maximum height of the ball using this kinematic equation. And for part B, we're asked to find the time that the ball is in the air. So we can solve for half the time from the launch of the ball to the top of the trajectory where the velocity is 0. And we also know that the acceleration is g. So that gives us 1/2 of the time that the ball is in the air. And by the symmetry of the problem, the ball comes back down in the same time. So the total time that it's in the air is 2 by t 1/2. A spring launches a ball at some initial velocity, and we're asked to find the time taken for the ball to fall into a bucket that's placed 2 meters below its initial position. So we recognize that the acceleration is uniform, so we can treat this as one interval of motion. So choosing our coordinate system, we'll have the positive y direction and the origin at the initial position of the ball, and the final position is thereby minus 2 meters. So knowing the initial position, the final position, the initial velocity, and the acceleration, which is minus g, given our positive y direction is upwards, you can solve for the unknown time t using this kinematic equation, and you'll get 2 solutions to choose from by solving the quadratic. And post your answer in the comments, and also your questions if something's not clear. A helium balloon is released and floats in the air to a height h with a constant acceleration a. Assuming that the total travel time is greater than 4 seconds, how much further does the balloon travel in the last 2 seconds than the first second? So the kinematic equation to use is y equals y0 plus v0t plus 1/2 at squared. And we have y0 is equal to 0 as our reference point, and v0 is equal to 0 as the balloon is released. So what we can do is take h1 is equal to 1/2 a by 1 second squared, h2 is equal to 1/2 by the acceleration by t minus 2 squared, and h is equal to 1/2 at squared. And then subtracting these two, we get this distance of the interval, and we can subtract h1 from this result to obtain the answer.